So now we're going to talk about an exception. So the exception to the rule only occurs if I'm talking about a D element. So if I'm in the D block, the exception might occur. Not every one of these occurs. So if you're running the electron configuration for an S orbital, this doesn't matter. If you're a P orbital, this doesn't matter. F orbital, it doesn't matter. It only happens if it's in the D block. So if I'm writing the electron configuration of a D orbital, of a D electron, or D element, then what I need to do is after I write it out, I need to say, is it one of the exceptions? All right, so the best way to practice to see what I'm talking about is we're gonna work through one. So let's work through CR. All right, so CR is number 24 here, so chromium. And so we're gonna write his electron configuration. You can see this when it's shorthand and when it's longhand, it doesn't matter. So let's just practice writing our shorthand since we already know how to do it the long way, and let's just save us some time. So let's do CR. Our noble gas is gonna be AR. So we're at AR, I'm here for S2. And then I'm here, so I'm in the 3, so 3D, 1, 2, 3, and 4. Okay, now, I'm gonna draw the orbital diagram because I think it helps you to see what's happening. So remember, S has one orientation, so it has one line, and then D has 5, and so you've got your 5 lines. All right, so let's look here. So here, my S orbital is completely full. My D orbital is only partially filled. So what happens is, if I have a D orbital, who's in this case, he's only partially filled, he might want to get to either half full or full. So this only happens if they want to be half or full. So I think about my D. So here, he's not half full. For him to be half full, he would need 5 electrons. Okay, so to be half full, you need 5 electrons. To be full, you need all 10. All right, so to be half full, he would need 1 more electron. I can't just give him an electron because then he would be an anion. I want him to be neutral. So what happens is I can move. These 4s electrons are in a higher energy level. So they're not as stable as these 3D. So what's gonna happen is, kind of think about this guy, this little empty spot, saying, come over here. So one of these electrons is gonna move over here, okay? So then what happens is, he moves, one of these electrons goes away, and now you have this guy. So one of those S electrons moves down. I still have the same total number. I still have 1, 2, 3, 4, 5, 6. I don't add, I don't remove. Okay, all I'm doing is moving, transitioning. So now my new electron configuration is going to be 4s1, 3d5. But that only happens, it can only happen if it's a D element and if it makes him half full or full. So let's do another one. So let's do titanium. So if we do titanium, so his noble gas would be AR, and then it's 4s2, 3d2. So you should get a little bit faster with these. So AR, 4s2, 3d2. So let's draw our picture. 4s, I've got 2, and then my 3Ds, I only have 2. So for him to be half full, he has 2. He's trying to get all of them to have 1. So that means he needs 3 more electrons. How many do I have here? I only have 2. So this is going to be an example when it doesn't happen. Because if I move these 2 here, it's still not half full. So this guy is going to stay just like he is. He doesn't move. Okay? So not all of them move. They only move if they're going to be like CR, to be half full, or if they're going to be full. All right, let's do another example. Let's do Cu. So Cu down here, number 29, his noble gas is Ar. So Ar, and then we're here, 4s2, and then, I'll go ahead and write that. And then here is 3, because it's one less, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9. So draw it out, 4s, my 3d, 4s has 2, and then he has 1, 2, 3, 4, 5, 6, 7, 8, 9. So he wants one more electron to be full, because to be full he would need 10. So one of these guys is going to come over here. So he's going to go away, and he's going to move over here. So now I would have 4s1, 3d, 10. Okay? So you can kind of look at the periodic table and realize, okay, he's got 1, 2, 3, 4 valence. So if he's got 4d electrons, he'll take one more to be 5. Okay? And then you can kind of think down the row. But then you can also think over here, down the row, what's going to happen over there with copper and silver and gold. All right. So now that you know how to write the rearrangements, this would be your final answer. So you move the one electron over, 4s1, 3d10. And so that is the end of doing the exceptions, but it only happens if it's a d electron or a d element that we're talking about, not any of the other times.